In this problem, we're doing another type of transformation called a rotation. And rotations are a little bit more complicated than reflections. First of all, you need to know what direction you're rotating, and those directions are either clockwise, like in this problem, or they're counterclockwise. So clockwise is the direction the hands on a clock move, so that direction. Counterclockwise would be the opposite. It would be moving that direction. So we're moving clockwise today. And then we have to know how much, and usually that's expressed in degrees of a circle. So in this case, we want to rotate this figure 270 degrees clockwise about the origin. Okay, so we've also got a point of rotation. So you could imagine this as if you put a pin down here and you tied a string and you just swung this around 270 degrees. In ALEKS, you'll be able to grab this blue bar and rotate it. And basically, every time you move it a quadrant, so if we move this bar from here to here, that would be 90 degrees. And your figure would end up somewhere in here. You move it another quadrant, that's another 90 degrees. So that would be 180 if it ended up over here. And when your bar is up here, the figure is going to be here, and that would be 270 degrees. When you do that, you'll find out this point right here ends up at -2, 3. So let me just kind of sketch in each stage of the rotating. So first, we get 2, -3. And this side points down this way. So what is that, 4 units? And then this side is going to be pointing this way, so that's 3 units, and 1 unit there, and like that. So that is after it's been rotated 90 degrees. And we do that again, and this point ends up at, let's see, the x was 2, so then the x goes to the 3 and -2. Yeah. And now this bottom side is pointing kind of up like this. So there's our 4, here's our 3. And this is sort of like it's been reflected across this diagonal line that goes through the origin when you rotate it 180 degrees. And then finally, to get to 270 degrees, this point is here, and this face is pointing that direction. And it's like that. So a little bit complicated to see. I would recommend you fool around with this, take a look at what happens when you rotate. But we started with this point 2, 3. And we ended after 270 degrees of rotation at -2. Sorry, this was 3, 2. Mixed those up. 3, 2. We started at 3, 2, and we ended up at -2, 3. And what happens in a rotation like this, every 90 degrees, you swap the numbers on the x and the y, and then the signs go according to their quadrants. So in this quadrant, the first quadrant, they're both positive. In this one, the x is positive, the y is negative. Here, they're both negative. Here, the x is negative and the y is positive. So that's a little introduction to how rotations about the origin work.